So a question is, how effective is this recall feedback system? Remember, the idea is that some things drivers cannot reasonably mitigate. So if you have an unmitigated hazard, possibly due to a design defect, it's really important to find those and fix them to maintain operational safety. But let's look at what happens in the real world. In a conventional system, it's far too often the practice that you ignore it if it's not reproducible. At some point, we've all heard in response to a software defect, something bad happened, your cell phone crashed, or your car did something funny or whatever, and you call to complain about it, and the first thing they do is they say, well, can you get it to do it again? Now, from a software engineering point of view, it's reasonable to ask to get it to do it again so you can take a look and investigate what happened. But if you're not able to reproduce it, they may just say, well, there's nothing we can do, and ignore it. There's tremendous incentive, especially in automotive systems, to ignore a software defect that's not reproducible and basically pretend it didn't happen. Now, sometimes what happens is you get a defect that reproduces, but not too often. And there's a way to say, well, maybe it's a software defect, but maybe it's a human error. Maybe the engine controller applied too much torque to the vehicle and the vehicle sped up when it should not have, or maybe the human driver pressed the wrong pedal. I mean, who knows? So you blame it on the operator. It's easy to blame the operator because how's the poor operator to prove they didn't do something wrong? So you see the cycle in safety critical systems. You ignore it if it's rare and not reproducible. If it happens too often to ignore, you blame the operator. And then when blaming the operator stops working, you say, well, we're going to fix it with education. We're going to train our operators on workarounds or mitigation. You see this especially in aviation, that if the aircraft does something wrong, you say, well, the pilots are trained to deal with it, so we don't have to fix it. Okay, that works to a degree, but there's some things that can't really be worked around. So you try, again, to blame it on the operator for not doing the workarounds, and you only very reluctantly do a software update. For those of you who followed the Boeing 737 MAX issues that included 2 crashes of aircraft, you'll find that this is the cycle that was followed. And eventually they did do a software update, but only after trying to blame the operators and so on. This behavioral pattern happens in every safety critical area. It's across domains. And why does it happen? Why does it persist? Well, partly there's a power imbalance between the victims and the system designers. If there's an airplane crash, the people and their families who were affected by the crash don't have a lot of power to go up against the large airframe manufacturers. That's what the regulators are for. But there's also a normalization of a moral crumple zone strategy. This is especially bad in automotive. A moral crumple zone is when there's an equipment failure, you find the nearest human and you blame it on them instead. And you typically have a narrative, well, the person should have done this thing to compensate for the equipment failure. But it may be that it was unreasonable to ask that, and what you're really doing is just finding someone to blame so that you don't have to fix the problem. There's pervasive poor adoption of software engineering practices. It varies from domain to domain, but it's very common to see domain experts writing software who do not have a particularly rigorous software engineering education, and that is leading to a lot of questionable quality code that ends up sometimes in life-critical applications. That's a persistent problem across many industries. And finally, one of the reasons that this pattern persists is that the feedback loop is called a recall. And recalls are bad and they bring legal consequence, so we try not to do recalls. So just calling the feedback loop a recall is actually harmful in practice.